All right, so you've got your graphing calculator handy. We're going to use that today. We are going to build off of actually Alina's question of number 34, and Jared, you were working on that too. You said you didn't make it a fraction or something. 33. Okay, we're going to work on problems that are like that. Your homework assignment is 5 questions long. However, each one has part A, part B, part C. So it's really 15 questions, which is about normal, for a homework assignment. Okay, so those problems we ended with, Alina's question, looked like this. They were both fractions. You're going to have a 1 plus in the bottom. You're going to have a number we're going to call C, like a squared plus b squared is c squared. We've got variable stands for that. There's always going to be an e. There's always going to be a negative. There's always going to be a k, and k is usually a decimal, and then a t. The bottom's pretty complicated. But when you see a 1 plus with an e in the denominator, you're like, I've seen that before. The numerator is really simple. The numerator is just the letter m. Each of those pieces plays a part, and what this equation models is something we call P, and P stands for population. We can use this equation to measure how a population grows and how it gets bigger or how it gets smaller. Populations look like this. Okay, a population could start out really small, and then it could have what we call a population explosion, where it turns the corner and the graph just all of a sudden heads really steep because it's just exploding in population. The population's growing really fast. And then sometimes, a lot of times, what happens in a trend of something, it's really hot and it's really popular right then, and then it just sort of dies off, kind of. Okay, and so then we level off like this. This kind of a shape has a name. We've got parabolas and we have hyperbolas, we have square roots. This shape is called logistic. It's a kind of shape that starts out really flat for a while, has an explosive steep growth, and then ends up flat again. This is called logistic growth. I kind of feel like vaping right now is in this pattern. If you listen to the news at all or follow posts or podcasts, you know that vaping right now is, I should say, the diseases, the number of deaths linked to vaping right now is in the explosive section. When vaping started, it was just kind of, the number of deaths attributing to vaping was pretty low. And in the last recent months, last about 6 months, it's like we've turned the corner, and hospitals and doctors all over the place are just, they can't understand. We are an explosive number of young people, young adults, and high schoolers that are getting lung disease and dying from vaping. I have some data to share with you when we come back from the holiday about how we're just in that explosive stage, and they're trying to stop it. Okay, Juul, the company, just yesterday announced that they've already made the decision to pull all their candy flavored stuff off. They're not selling it anymore. And so yesterday they announced they're pulling their mint flavor off as well to try and stop the trend. Anyway, I digress. Okay, so this population's growing. It could be rabbits. It could be bacteria. It could be people in a city. Eventually, population levels off. Okay, what happens is maybe you get to, for a while it was Oregon. Oregon was the hot place and people were moving to Oregon. Now I feel like it's Idaho. A lot of people are moving to Idaho or Texas maybe. And it's like you have a small population and then it grows really big, and then all of a sudden the population kind of levels out because all of a sudden you kind of run out of space or you run out of resources. There's just not enough stuff around to support the population. Okay, how do you know when a population is going to level out? All right, if you could zoom in and label the end of that with the letter M. M stands for max, and that max right there matches the number that is in the top of the equation. The top of the equation will tell you what the top of the graph is going to be. At the top of the graph will level out at that particular number. Okay? So you can tell that right away from a graph. So let me give you an equation, an actual real-life equation, came from a real place. P equals 1301642. So if we put the commas in there, that's 1,301,000. 1 plus, it's always a clue when you have 1 plus down there, 21.6 e to the negative 0.505 t. All right, this is a real equation. This real equation came from Dallas, Texas. It came from the last time we did a census. The United States does a census. That means they count everyone every 10 years, every decade. So next year is the next time we'll have a census, Census 2020. So this data came from the last time we did a census, which was 2010. And then before that, 2000 and 1990 and whatever. So next year, your household will need to participate in the census. Okay, it's not for like taxes or illegal immigration and people have all these rumors. They just are counting people. That's it. To see, and that helps adjust how many like representatives our state gets, because they count everybody in our state, and then we either get more or less. So some states lose representatives because their state doesn't have as many people in it anymore, and other states are given representatives because their state is bigger. Okay, what could you tell me about Dallas just from looking at that equation? How many people? Okay, so just from looking at that equation, we can tell, and that would be like question A of your homework. What's the maximum number of people that could live in Dallas? And you can tell that right from looking at the equation, that the max is 1,301,642. Now that's not counting all the suburbs of Dallas, it's just counting Dallas itself. Okay, so that at the time, back in 2010, that was the maximums. How many jobs are there available? People leave if there's not a job available. How many places to live? If there's not housing, then people will move. So that was the maximum supported community you could have in Dallas. Okay, next thing, you could be asked about this question. How many people were there in 1990? Excuse me, let's do 1970. All right, so this is where your calculator comes in. 1970 is a time. The variable is t. But your calculator is a little finicky. And when you type that equation into your calculator, you have to put the denominator in parentheses. Otherwise, you'll get a totally whacked out answer. All right, so I'm going to switch screens here and go over to my calculator. So if you could, in your Y1, please put in, okay, in your Y1. So. All right, you're going to put in 1,301,642 divided by parentheses. That parentheses is key. 1 plus 21.6 e to the negative 0.505 t, we'll use x, and then close your parentheses. Okay, our calculator will now figure this out for us. Trust me, you don't want to plug 1970 into this by hand. Like, you don't want to type all of that in. Let your calculator with the vars do the work. So quit out of here, pull up Y1 with your vars, and let's put 1970 in there. Okay, but we're putting in 70, not 1970. We're just going to use the number 70 to represent. Okay, and so if you just do that, Y1, and then put 70 in, your calculator will do all the computations for you. Okay, 1,301,642. That means it met its maximum already in 1970. Okay, what if I wanted to do, if this was 1970, what would the year be that it started keeping track? What would 0 be? If 70 was 1970, what would 0 be? 1900. Okay, so let's try 0. Let's try the beginning. When they started keeping track, then we have to put time in 0. So let's do our vars, and let's put 0. Enter. When they started keeping track, doing the first census in 1900, 57,590, let's say, let's round that to 595. Okay, so can you put that number in your notes? All right, so in our notes, I'm going to change this to a 1900. Okay, 1900, we're going to plug in time is 0. And so we used our Y vars, and we plugged in time to be 0, and we got 57,595. Let's round it, people. Okay, so when they did that census back then, that's how many people were in Dallas. Let's do 1940. So how many people in 1940? All right, and so we'll do our vars, and we'll put in 40, just under its maximum, right? So that's a huge lot of growth for the city of Dallas in 40 years, almost double, okay, its growth. And so we check Y1 of 40. Now we're up to 1,301,641. So just pretty much at its max, only one person off. Okay, last question. So here would be like a part D. When did Dallas reach 1 million exactly? All right, your calculator cannot tell you that answer. You can't just do vars. When you do vars, you can only plug in a time. 1 million is not a time. 1 million is a people. And so you're going to have to do the same kind of math you did yesterday. So we're going to take 1 million, and we're going to put it equal, 1, 2, 3, there we go, got enough, to the Dallas equation, which is 1,301,642 over 1 plus 21.6e to the negative 0.505. This is why I had you practicing this in your homework yesterday. Okay, I have total confidence in you. You guys can solve this problem. Even though it looks crazy scary, I know you can do it. Okay, you're going to drop a 1 under the million, and you're going to cross multiply. So put the million outside of 1 plus 21.6e to the negative 0.505 t. And on the other side, we'll have our 1,301,642. So cross multiply, but just put it on the outside of parentheses, and then divide. We're going to divide both sides by a million. Divide the other side by a million. When you divide by a million, the 1 plus 21.6 e to the negative 0.505 is on one side, and 1,301,642 divided by a million is 1.301642. We just have a decimal now instead of having the million. What do I do next? Yeah, it's basic math, right? You subtract 1. And so we have 21.6 e to the negative 0.505 t equals 0.301642. I just subtracted 1 legally from both sides. Okay, what's the next legal move? Divide by 21.6. So e to the negative 0.505t would be 0.301642 divided by 21.6. I haven't even touched my calculator. I didn't need to. Okay, now what? What do I want to get rid of next? How do I get rid of that e? I'm going to use a natural log. So I'll use a natural log on both sides, which will allow me to pull the power, negative 0.505, out to the front. And then I'll have ln e, which will cancel each other out. And then in the parentheses, I'll have 0.301642 divided by 21.6. Notice I still haven't used a calculator. The ln and the e cancel each other out, and so I only have one last move for me to do to figure out the answer to this. So how do I get time alone? Divide by 0.505. All right, so it's ln point, keep doing that, 0.301642 divided by 21.6, close the parentheses, divide that by negative 0.505. Okay, now you can finally type that into your calculator. And that should tell you the year when Dallas first reached 1 million people. Okay? So what do you get? Well, I know, but what actual number do you get? 8.45. Is there any more decimals beyond that, or is that exactly what it was? Yeah. Tell me. Give me at least 3. Okay, so 8.458. That translates to the year 1908. And so the answer of when Dallas got to 1 million people, 1908. It was having its explosive growth in those years right in there. Okay, so you'll have an easy question like, what's the max? That should be easy. You just look at the equation. You'll have some calculator problems where you just drop the time into your calculator using your VARs. And then you'll have a couple of the harder ones where you're going to have to cross multiply and then find your answer on your own doing all legal math to both sides.